In this video, we have two integrals to evaluate, and we'll be using the arctangent integration formula. And by that, I'm talking about this formula here, the first one. If you have an integral of this form, du over a squared plus u squared, a squared or a is a constant, u in general will be a function of x. If you have it in that form, then the value of the integral is given by 1 over a arctan of u over a plus the constant of integration. Now, if you don't have access to this formula, or the instructor doesn't let you use the formula, you can still work these problems using a trig substitution involving the tangent function. You can also use a combination trig and a u substitution. So for the first one, you can see it's in that form for the most part. Got du over a squared plus u squared. So you can look at this as, you can write this as 3 squared, and the x minus 3, you can say that's your u, and then it's squared. So notice, if I let u equal to x minus 3, then du would be the derivative of that, which would be 1, which would be dx. So this would be the same thing. This would be du. If I let u equal to x minus 3, then this would just change to du. This would still be 3 squared, and this would be your u. And you could go directly to that formula. This is equal to arctan of u over a. Now this were a 2x minus 3 squared, and you couldn't do it that way. You'd have to first set up the u substitution. But here, since the derivative of x minus 3 is dx, it works fine. So you would just say this is going to be x minus 3 u over a. A is 3 plus the constant of integration. And remember, the coefficient here was 1 over a. In our case, a is 3. So the answer to the first one, using that formula, is 1/3 arctan of x minus 3 over 3 plus the constant of integration. Now for the second one, this is to the 4th power. We want a u squared or an x squared here. So let's do this. Let's say we can write this as x squared quantity squared. So we can get it exactly in the form that we want it. So then for this one, u would equal to x squared. So du would equal to derivative of x squared would be 2x, and we have dx. Divide through by 2. 2's canceled out here, so x dx would equal to du over 2. So I can rewrite the integral then. In terms of u, the x dx will be du over 2. I'll put the 1/2 out in front. This will be du, x dx, and the 1/2 out in front. Then x squared is u, so this will be u squared plus the 16. You can write that as 4 squared. So this would be a squared, 4 squared. So a is 4. And you got u, and of course u is x squared. From this, we can go directly to the formula. So this is going to be, just ignore the constant sign in front. So just look at this part of it here. Integral of du over u squared plus 4 squared. According to the formula, this is going to be arctan, and this would be u over a. And let's go back to the original variable. So u, in our case, is x squared. So this would be x squared over a. A is 4 in this case. And then the coefficient is, got the 1/2, but then the formula has 1 over a. So this would be 1/4. So 2 times 4 is 8, so this would be 1/8 here. Arctan of x squared plus 4. And then this would be plus the constant of integration. So again, this one we set it up as terms of u, had in this form. And we go directly to the formula arctan of u x squared over a, which is 4, plus the constant of integration. And we had coefficient here of 1/2 along with the 1 over a, which is 1/4. We get the answer 1/8 arctan x squared over 4 plus the constant of integration. Thanks for watching, and we'll see you next time.